You know that sound, right? That grinding, churning roar of a concrete mixer at a construction site? It's the sound of progress, for sure, but it's also the sound of old-school, brute force engineering. It's loud, it's disruptive, and honestly, it hasn't really changed in decades. Well, all of that is about to change. That whole paradigm is being completely rewritten from the ground.
I mean, just think about that. What if that massive 30-ton machine could just glide through your city streets, silently, and then when it gets to the job site, it does its entire job without the diesel engine even running? It sounds kind of like science fiction, doesn't it? But this isn't some far-off concept. This is the new reality, all thanks to software.
So here's the deal with the old diesel mixers. They are just incredibly inefficient. They're constantly burning fuel, constantly making noise, especially when they're just sitting there at a job site idling, just to keep that big drum spinning. But now we've got a hero in this story, the hybrid electric system. And look, it doesn't just reduce emissions, it completely eliminates them when it's working on site. We're not talking about a small tweak here. This is a total game changer, a massive leap forward.
All right, so let's get into the heart of how this all works. You see, the battery and the electric motor, they're powerful, no doubt, but you can think of them as the muscle. The real magic, the absolute revolution here, is the brain. It's the intelligent software that's running the whole show.
And that brain is called the Supervisory Control Unit, or SCU for short. This thing is literally the vehicle's central nervous system. It's making thousands of calculations every single second to make the diesel engine, the electric motor, and the battery all work together perfectly. It's like the conductor of a very, very complex orchestra, making sure every single part plays in perfect harmony.
Okay, to really get a feel for what this SCU does, let's follow one of these smart mixers through a typical day. We're going to see how the software thinks, from the moment the driver turns the key in the morning, all the way to shutdown at the end of the day. Now, the SCU isn't just winging it. It operates from a very strict and very structured playbook. In engineering, we call this a state machine. You can see its 9 main operating modes right here, from S0, which is sleep, all the way to a fault state. And having this playbook means the truck always behaves exactly how it's supposed to, safely, predictably, and efficiently no matter what happens. So the day kicks off. The driver turns the key. But before anything else happens, before a single wheel turns, the SCU wakes up and does a full systems check. It talks to all the other computers on the truck, and, this is the most important part, it runs a complete safety check on the high-voltage system. Nothing moves until it gets a green light on everything. And the key to that safety check is something called the high-voltage interlock loop, or HVIL. Think of it like a continuous, fail-safe heartbeat. It's a simple, low-voltage circuit that runs through every single high-voltage connection. If any one of those connections comes loose, even a little bit, that heartbeat signal is broken. The SCU sees it instantly and is hardwired to completely cut power to the 400-volt system. It's the #1 safety feature, the absolute bedrock of the whole system. Okay, all the checks are passed, we're green across the board. The SCU switches to state S3, pure electric drive. The diesel engine is completely off, and the truck just glides out of the plant. It's moving through the city, powered only by the battery. This is it. This is that quiet truck we talked about at the beginning. No exhaust, no engine roar. It's really something to see. But, okay, what happens when the driver needs more power than the electric motor can deliver on its own? This is where the SCU gets really clever. It pulls off a maneuver called torque fill. See, there's always a tiny delay when you start up a big diesel engine. The SCU knows this. So in that split second, it tells the electric motor to kick in with an extra boost of power, perfectly filling that torque gap while the engine gets up to speed. And just look at the difference this makes. In a normal hybrid, you get this huge jolt when the engine kicks in. The driver feels it, and all the gears and shafts feel it too. But with the SCU's torque fill, that jolt is almost completely gone. We're talking a reduction of over 94%. The result? The acceleration is incredibly smooth, and it puts way less wear and tear on the whole truck. All right, so the truck has arrived at the construction site. And this is where it enters its most important mode, State S6, what we call Stationary Electric Power Takeoff, or ePTO. The moment it's in position, the diesel engine just shuts down completely. The only thing you hear is this quiet hum from the electric motor spinning the drum. It's all running off the battery. For cities, this is everything. No noise, no fumes. But here's something amazing. The SCU's job just changed. It's not just a truck controller anymore. It's basically become a material scientist. It's not just spinning the drum. It's using the motor to feel the concrete. It keeps the speed perfect for quality. It acts like a digital slump monitor.
measuring the motor's effort to know exactly how workable the concrete is. And if the mix starts to get too thick, it even knows to rock the drum back and forth to break it loose. It's actively ensuring the product is perfect.
And this really shows you how smart the system is. It's all about context, especially with safety. So, let's say a serious fault happens while the truck is parked. Bam, the SCU instantly shuts down the high-voltage system. Safe and simple. But what if that exact same fault happens while the truck is driving down the highway? Well, slamming on the brakes or killing all power would be a disaster. So instead, the SCU is smart enough to go into a limp home mode. It gently reduces power and gives the driver time to safely pull over.
So we've seen it in action. Let's talk about the payoff. Why does having this intelligent software at the core matter so much?
Well, for one, it matters because the SCU acts like the ultimate traffic cop for power. We call this torque arbitration. At any given moment, you've got the driver asking for power, the brakes trying to regenerate energy, the drum needing to spin. The SCU is juggling all these requests. But it has one simple rule: safety always wins. As you can see here, things like anti-lock brakes and stability control have absolute top priority. Nothing else happens until the SCU knows the truck is safe.
And, of course, it matters for the environment. By letting the engine shut off on the job site, that ePTO function cuts out more than 22 pounds of CO2 for every single hour of idling. Now think about that. One truck, 1 hour. Now multiply that by thousands of trucks all working every day in cities all over the world. The impact is just massive.
And really, it all comes down to this. This isn't just a better truck. It's a completely different way of thinking. As this quote says, we're shifting away from just brute mechanical force and moving to smart electronic control. And that opens up a whole new world of safety, efficiency, and even product quality that you just couldn't achieve before. So what's next? If this is what software can do today, where is all this heading in the future?
Well, the future is all about being connected. Imagine the truck using GPS to see a big hill coming up, so it saves battery power for the climb. That's predictive energy management. The SCU software will get better over time with over-the-air updates, just like your smartphone gets new features. And it'll constantly send health data to the cloud so you can fix a problem before it becomes a breakdown. The truck just keeps getting smarter.
And that leaves us with one last big idea to think about. We've just seen how we can take one of the most basic, loud, brute force machines out there and give it a sophisticated, intelligent brain. So if we can do this for a concrete mixer, what does that mean for all the other machines that build our world? The cranes, the bulldozers, the farm equipment. I think it's pretty clear the software revolution for heavy machinery is really just beginning.